2.3 is going to continue on using our addition property and our multiplication property and kind of rolling it all together so that you've got this, like I always talk about it as a salad bowl or a combination of rules where you have to pull apart these individual rules to know what you need to do first. And so when I teach this algebra and these solving equations, I try and make sure that I'm always doing the same thing. And so developing the strategies in the addition property, I said, let's pick on the x terms first and then move the whole numbers around. When we were doing the multiplication property and we had some fractions, I said, rather than learning it different ways, let's develop this strategy that is going to obliterate the denominator. And so in all of these, I try and be consistent. Now that we're into the 2.3, I like to reinforce to people that we are doing the addition property, then the multiplication property. So it's kind of like reverse BEDMAS when you're trying to solve an equation. You actually deal with adding and subtracting things before you divide them out and solve for x, unless you have fractions and you're going to multiply to clear for that denominator. So I'll try and be consistent in these. I know it feels like a lot as you're combining these rules, but let's take a look at 2.3. So 2.3, no notes, kind of winding this one up. It's really just what we've been doing so far in chapter 2. I would start by picking on the x terms in this, but I only have one x term. So the next thing I'm going to do is try and get the x's all by themselves and the whole numbers all by themselves. You can solve for a number equals x, but I'm going to be consistent, like I had said, with x equals a number. The only thing that that does to us sometimes is gives us a negative x, and you could have maybe worked around. But if you have to know what the answer is, so you know how to get to the answer, that's not a really consistent strategy. And so let's do these the way that we've been talking them through. So we'd have plus 5 on both sides. That would get rid of my whole numbers over on the left-hand side where I want just x terms, and I'd get 4x equaling 12. So I did the addition property, and now I'm doing the multiplication property. And getting just the x alone, I'm dividing by the coefficient and dividing both sides by that same number. So my final answer is that x equals 3. And just one time today, just to remind you, you can always check your answers other than at the end of the assignments or on the key. I can sub in and solve for these ones. And I'd get 12 minus 5 and 7. And that checks out. 7 is not your solution. Your solution is that x equals 3. But the fact that the two sides of the equation are in fact equal shows that this is a truth, shows that this is a correct solution. I'm going to do D. Oh, let's do B next because it steps up in difficulty. So I'm going to start by subtracting 9 from both sides. I get 6x equaling a negative 24. Dividing both sides by 6, I get x equals a negative 4. We'll do D and E, and then I'll leave the last two for you to try a little bit more on your own. So D, I've got more going on. I'm going to pick on the x terms first. I'm going to move the x terms to the left-hand side and then move the whole numbers to the right-hand side. I'm going to use the addition property first and then the multiplication property. So I'm going to start by subtracting 9 from both sides, and what that's going to do is get rid of the 9x over on the right hand side and bring it over to the left hand side. So I get negative 4x plus 3 equaling negative 21. Next thing I'm going to do is pick on these whole numbers. So I don't want the 3 over here on the side where I like just x's. I'm going to subtract 3 from both sides. So I get negative 4x equaling negative 24. Then I divide by that coefficient, in this case, that negative 24. So I get my final solution of x equaling a positive 6. One more, just warming things up here this morning, or today, whatever time you're watching this video. E has some distributive property to do. So I have to distribute that 5 and then carry on. So we have 5x minus 15. Recopying that minus 2x equaling x plus 7. in our strategies, I said it's often simpler to gather up those like terms first. So working on just this left-hand side, the 5x minus the 2x would give me a 3x, recopying the negative 15, and recopying the right-hand side of that equation. Just to be consistent, I'm going to pick on the x terms first and start by subtracting x from both sides, because that's going to move the x away from this right-hand side of the equation over to the left-hand side. So that's gone. 3x minus x gives me a 2x, recopying that minus 15 and recopying the positive 7. Now I can pick on my whole numbers. I'm still not ready to divide anything. I'm not done with the addition property yet. So I'd add 15 to both sides. So I get 2x equaling 22. And dividing both sides by 2, I get a solution that x equals 11. I think in those 4 examples, it gives you a lot to kind of refresh your memory and kind of put it all together. The 2 at the bottom, I'm going to show my work real quick, and then you can check as you go here. Sometimes you do get fractions as answers. We've seen that once already in the notes. So give those ones a check, and things are going to get harder with fractions on the next page. So these ones really are a bit trickier. Remember, things are easier if you rid yourself of the denominator with that strategy that I was saying works all the time. You can do this by multiplying the equation through by the LCM of the denominators present. That's how you pick the number. So the general steps that I was coaching you through was 1, choose the number, and that's the LCM of all denominators present. 2, multiply everything by that number. 3, cross out the denominators. And then 4, write everything without fractions. So write it all above board. So write out without fractions. And then you can carry on in the way that we've been solving these ones. So let's take a look at these ones with that strategy in mind. So you could get to the answer another way, but like I'm saying, if you have one strategy that works, when things get harder, you can always use it. So for A, I have a denominator of 5, so the number that I'm going to choose to multiply everything through by would be 5. So multiply this one by 5. Actually, you know what? I'm going to do this without squishing it in because I think that makes it a little bit harder to see. Come on, erase. Okay, so I'm going to rewrite it. And I'm going to multiply everything through by 5. So each of the terms gets multiplied by 5. So I've chosen the LCM as 5. I multiplied everything through. Now I'm going to cross out the denominator. So sometimes easier to switch colors for me with this one so you can see what's going on. The 5 divided by 5 is 1. It goes away. That's the only one that I have to do to cross out. So now the next thing I can do is write it all without fractions. So I get x minus 15 equaling 20. And this step is certainly worth your while, I think, oftentimes to make things easier. So I'm going to add 15 to both sides, and I get a final answer of x equaling 35. I'm going to do B. I don't know how I don't know my alphabet on these ones, but you just have to pardon me on that. So B, I'm going to choose my number. So I only have one denominator here, so I'm going to rewrite this with some space because everything is going to be multiplied through by 3. That's what's going to allow me to wipe out or get rid of my denominator. So everything's getting multiplied by 3. Now I have to cross out any denominator. So I'm going to switch colors again, just so you can see it. The 3 divided by 3 goes away. Now I can write everything without any fractions. Everything should be all above the fraction line. So 2x plus 15 equals, oops, not 42, 39. I'd subtract 15 from both sides. And I know full well you can get to this answer another way. Equaling, what's that one worth? 24. And x equals a 12 on that. So G and D are getting trickier. These ones would be harder to do with a different strategy. And so for G, I'm going to use my guide over here, use my approach. So I see fractions and I have to take a big breath because I'm like, great, now I'm doing algebra with fractions. I'm going to rewrite it so I have some space to work. And I'm going to choose a number that would get rid of all my fractions. I'm going to choose the LCM if you like thinking of it that way. So when I take a look at my denominators, 20 is going to be that number, right? I'm going to multiply each of my terms by 20. Then I'm going to cross out any of these denominators. So this one's easy. The 20 divided by 20 just goes away. All these other ones are going to leave something over. So 20 divided by 4 leaves me with a 5. 20 divided by 5 leaves me with a 4. And this is where things get a little bit harder to see and harder to kind of collect up, like figure out where the heck am I at? So 5 times x would give me a 5x, writing this all above board. I have minus 4 times 4, so minus 16 out of that mess in the middle there, and that should equal 19. And at this point, this step is the one that's worth your while. I mean, it's definitely a little bit much to get through those, but once you're here, the world gets a lot simpler. So I get 5x equaling 25. We got this. X equals 5 as a solution. And if you wanted to, you could always verify that one. And I did that wrong. 19 and 16 is not 25, it's 35. Somebody was probably screaming at me in the comments there. And my solution is not 5, it's 7. Sorry about that. Okay, let's see if I can do D correctly. We're back to these easier ones a little bit. So we're going to choose a number that would get rid of my fractions. I'm going to multiply everything through by that number. Then I'm going to write it all above board. So back to the simpler ones here, where 4 is going to be that number that would get rid of my denominator. So everything gets multiplied through by 4. I do this crossing out business, and I write it all above board. So I get 8 minus x equaling 12. And now I just solve for x. So I would subtract 8 from both sides. And this might be where you deviate and be like, well, I'll just put the x's on the other side. Totally valid if you want to. I'm going to be consistent and try and keep it all the same. So here I get, did I do that wrong? Oh no, we're good. Divided by -1, divided by -1. X equals a -4 as an answer. Okay, so the last two. I'm going to put the answers up. In class, we're definitely going to take our time working through these ones. If you're working through this as the key on Moodle, I would suggest, yeah, really checking your work as you go here. So these are the solutions if you get there. And it's a fraction on the last one. I certainly don't want to verify that one. So we'll give those two a try, and in class I will show you line by line. I will reinforce the strategy that I've gone through. So choosing a number, maybe I'll just even choose the number here. Multiply everything through by that number, cross out your denominators, write it above board, and then solve for x. So if you can make it through those ones, you are well on your way. We're going to finish up this 2.3 with some oddballs. And so these are some special solutions. These are some things that I can't help but give kind of personalities. So if you dutifully go through and are solving or using all the strategies for solving equations, and you get down to weird things, you get down to something that says 2 equals 2 or 0 equals 0, or, you know, an absolute truth. So it could be 0 equals 0. It could be 3 equals 3. Oh, that's not a 3. 3 equals 3, right? That is a line of truth. When we have a truth, what we say is that it is an identity. And so X could be anything. These ones are the ones that are really easy to please, and X could actually be anything in there. I'll come back to that as we go through the examples. The other example here, the other, so this one, X is an element of all real numbers, is sometimes how it gets written. So we're just going to say that identity is our answer. The other one is a contradiction. So you're going through and using all of the strategies that you've been learning in chapter 2, and you get down to a line of garbage, I always call it. It's just an absolute nonsense line, like 2 equals 1. No, 2 doesn't equal 1. It never does. And so if you get down to a line of garbage, these are the ones that are impossible to please. So they are a contradiction. And it means there are no solutions for this one. Okay, so these ones, X could be anything. Or X is an element of R for an identity because they're an absolute truth, and they're the ones that are easy to please. Sometimes I write it as these ones. And the contradiction, there's no solution. There's no value of X that would actually satisfy these things. And so this is the way I kind of anthropomorphize these ones. These ones are easy to please. Because you could literally pick any value of X and say, that is an answer. These ones are impossible to satisfy. You are never going to make it so that the two sides equal. There is literally no value of X that would ever make them true. So let's see how these ones work. We've kind of gone through them in some sketchy notes here at the top. Let's go through with the strategies that we know. So for this first example, I'd have the 2 to distribute through, and I get 2x minus 6. On the other side, nothing to do with the brackets. I'm just going to recopy it. And at that point, I have a line of truth. But let's carry on with this one. So I would pick on my x terms first and subtract 2x and 2x. And I get, oh, look at that. I get negative 6 equals negative 6. That's another line of truth. At this point, hopefully you would say that this is an identity. There's an infinite number of solutions for these ones. Okay, so for the next one, we take a look at the contradiction example. I'm going to distribute this across. So I get 6x minus 15 minus 4x equaling 2x plus 1. Gathering up my like terms, I get 2x minus 15 equaling 2x plus 1. You might notice that there's something funky going on here. I'm going to pick on my x terms first and subtract 2x to bring it over to the left. And when I do that, things get weird. I get down to this line of garbage. Negative 15 does not equal 1. And this is not your answer, but this tells you that this is a contradiction. It means that there is no possible solution for these ones, that you can never find an x value that's going to satisfy this equation and be a solution. So let's take a look at these ones. There's 4 more here for us to go through. The next 2 are fairly straightforward, and you know that I would do it. I put some fractions in the bottom ones, and so we can practice our strategies for dealing with those fractions. I'm going to show us all of these ones all the way out. 3x minus 12, recopying, gathering up my like terms, and I get x minus 12 equaling x minus 12. You might notice at that point that that is awesome. You've got an identity at that point, but you could keep going. Pick on your x terms first, and I get down to another line of truth. It doesn't matter what your line of truth is. This is not your solution, but this is your indicator that the solution for this is anything, that this is actually an identity. This one over here, good old distributive property first, rewriting the rest of the equation, gathering up my x terms, picking on my x terms, moving them to the left, I get down to something strange. I get down to a line of garbage or a line of nonsense here. And that means this is not my answer, but my answer says that this is a contradiction. It means that there's actually no value of x that would ever satisfy this thing. This one's always going to be a grumpy guy. The smiley face and sad face are not your answers as well. So for the last 2, I think I have time to do these ones all out. So they may be a contradiction, they may be an identity, or they may be like one of the regular ones, the consistent solutions, and so where you actually get an x value. So let's go through these ones. They also do have the fraction, so we're going to choose our number. So I get 12 as the number I'm going to choose, and I'm going to rewrite this one so that I have some space to multiply it all through by that number. So 12 is the number. I'm going to switch colors because I've multiplied everything through. The next step is to cross things out. So 12 divided by 4 would leave me with a 3. Nothing to cross out on this middle one because there's no denominator. On the right-hand side, 12 divided by 3 would leave me with a 4. So writing everything out above board takes a minute. Work slowly because we have a 3 times all of this stuff here. And so I put brackets around it so that I can see it's 3 times all of this. I'm going to redo that one. And then similarly, I have a 4 times all of this. And we haven't seen questions like this yet. That is an extra wrinkle to those fraction type questions. So I've written everything above board. Now I should have the skills with the addition and multiplication properties to solve for x. I'm going to have to do some distributive property. So I'd have 9x plus 3 minus 24. And on the right-hand side, I distribute the 4 through that bracket. So 4x plus 4. I can gather up some of my like terms. 9x minus 21 equaling 4x plus 4. Just checking my key, I'm not going wrong. I'm going to pick on the x terms first, moving them over to the left-hand side. So I subtract 4x everywhere. That would leave me with 5x minus 21 equaling a 4. And now I'm going to add 21 to both sides. This one is not a contradiction or an identity. This one is actually like all the others. There's actually going to be a solution. I get 5x equaling 25. Keep going. Divide both sides by 5. And I get x equals a 5. And we are certainly past most people's powers of intuition. We certainly need a strategy for dealing with that because you're not going to look at this and see, oh yeah, x equals 5, I'm pretty sure. Okay, so one last one here. a lot going on in these ones. We're going to pick our number. That's going to be a 4. I'm going to rewrite it so I have the space to multiply everything through by that number that's going to get rid of all my fractions. So multiply by 4, multiply by 4, multiply by 4. Everything gets multiplied through. You don't have to switch colors, but I'm going to. Now I can get rid of any of my denominators. Here I have a 4 divided by 4, leaves me with a 1. So I don't even bother writing it. 4 divided by 2 leaves me with a 2. This one should be a little simpler to write as everything above board. And now that I have everything above board, I can continue on gathering up these whole numbers on the left-hand side and then moving my x terms together. And oh, weirdness, I get 3 equals 0. I get down to a line of nonsense. I get down to a line of garbage. And again, this is not my answer. You could have different lines of garbage down here, but this tells me that this is a contradiction. As equations go, it's never going to be satisfied. There is no value of x that would ever make the left side equal the right side. So we've gone through a lot with the fractions. We've gone through a lot with the oddballs here. So really give up to the end of chapter 2.3 priority in doing your homework, because we're going to build on those skills as we move through. And certainly by the time we get launched into word problems, understanding the mechanics of the algebra is absolutely critical. So prioritize your homework if you can up to the end of 2.3, and we'll continue on with, kind of making this transition towards the word problems in the next couple sections.